Up till now, in our previous tutorials, we have discussed in detail about nitrogen operations and their calculations. Now we'll start our learning about nitrogen equipment and its operating. So let's move to the nitrogen pumping unit and learn about its major parts, or we can say the main subsystems installed in a nitrogen unit. So now we are moving towards this nitrogen pumping unit with an objective to learn about its major parts, their working and operating. By the way, the nitrogen unit which we will discuss during our learning is manufactured by Yasir Group. Talking about the major parts of nitrogen pumping unit, a typical nitrogen pumping unit composed of the following 6 major parts. The number 1 is LN2 storage tank, which is shown here in this particular diagram, the LN2 storage tank. The second part is LN2 boost C pump and low pressure manifold, which is installed over here. We will discuss in some detail in our next slide. Then comes the control panel, which is shown over here. Then number 4 is high pressure pump, also known as cryogenic triplex pump, which is shown over here. Then heat exchanger, which is installed here in this particular unit, and number 6 is engine or power source. So the 6 major components include, starting from this side, LN2 storage tank, LN2 boost pump and low pressure manifold, control panel, high pressure pump or cryogenic triplex pump, heat exchanger and the engine, also known as power source. Now let's discuss some detail about each of these components. So the first component is LN2 storage tank. The storage tank is the starting point to understand and operate a nitrogen pumper. What does it mean? It means that if we want to understand the nitrogen pumping unit and also want to understand that how to operate this particular unit, then the starting point is liquid nitrogen storage tank. That is, we must know all the engineering design of this particular component, that is LN2 storage tank. It is used to store the liquid nitrogen which is very cold, -320°F. Thus a special type of material and design has been used in its construction, which we will discuss separately in our upcoming tutorials. Second part is LN2 boost C pump and low pressure manifold. The LN2 boost C pump is a vital part of the nitrogen pumping system. Without it, the amount that a pumper could pump would be limited. The suction of the cold ends must have a continuous supply at the required pressure to pump against pressure. Without the C pump, it would be very difficult to prime and keep prime on the cold ends. To supply LN2 to boost pump and then to triplex pump, a low pressure manifold composed of cryogenic hoses and plumbing has been installed. Now let's understand all these points using this diagram. So here we have these two C pumps, also known as boost pumps. The purpose of these two C pumps is that to take the nitrogen from this tank in liquid form, then provide this liquid nitrogen to the next component, that is high pressure pump or cryogenic pump. So if these two C pumps would not be here, then what will happen? The required quantity of nitrogen will not be provided to the triplex pump, so our operation will be disturbed. And to perform this activity, some hoses and plumbing has been installed to provide the liquid nitrogen from this tank to this C pump or boost pump, and then from this boost pump to the triplex pump. We will understand all these manifolds and all these linings in our separate tutorials in detail. So let's move to the next part, that is control panel. During preparation and execution of nitrogen treatment, the LN2 is controlled and directed through various stages before it leaves the pumper. The control panel is the center for this activity. What does it mean? It means that during the operation we have to monitor, observe and control different parameters. For example, we have to adjust the nitrogen rate, we have to adjust the pumping pressure, we have to adjust the engine RPM, we have to adjust the coolant temperature, we have to adjust other stuff as well. So all these things, all these parameters are controlled using this control panel. So it is the control station for nitrogen unit. We will discuss this control station or control panel separately in our upcoming tutorials. Then comes the high pressure pump, also known as cryogenic triplex pump. The high pressure pump, cold end or fluid end. Mostly in the case of nitrogen unit, we call this triplex pump as cold end. We may also call it as fluid end, but mostly we call it cold end. So the function of this cold end is to perform the same function as the triplex pump on a cement pump or a stimulation pump, that is to pump the liquid. In this particular case, because we are pumping nitrogen, so the designing will be in such a way that it could handle the low temperature liquid nitrogen. This is mentioned over here that the major difference is that the fluid being pumped is LN2. So the components that come into contact with the LN2 must be made of appropriate materials so that they could handle the low temperature liquid nitrogen without getting wear and tear. These are the diagrammatical view of high pressure pump or cryogenic triplex pump. This is the front view, this is the side view. We will discuss in detail in the upcoming tutorials. Then comes the heat exchanger. Up till now we have discussed that liquid nitrogen will start from the liquid nitrogen storage tank, then will come to the C pump, then will come to the triplex pump. After the liquid nitrogen exits the triplex pump, it is still in the liquid form. So we have to convert that liquid into gaseous form. This is done with the help of heat exchanger, which is installed over here. This particular component on the back side of this component, we have heat exchanger. The vaporizer on the nitrogen pumper converts the liquid nitrogen from a high pressure liquid to a high pressure gas by heating it. That particular component is known as heat exchanger, and its function is to convert the liquid nitrogen into gaseous form. Engine or power source. To perform all these activities, to run the triplex pump, to run the boost pump, to perform the working of this heat exchanger, we need a power source, and that power source is our engine, which is generating hydraulic energy and is providing to all the components for their function. It is mentioned over here that a heavy duty diesel engine is part of the nitrogen pumping unit. It produces and then supply all the required hydraulic energy during operation of nitrogen pumping unit. That was the discussion about the introduction to nitrogen pumping unit and its major components. I am very much hopeful that you got understanding regarding what we have discussed. Thank you very much. See you in the next tutorial.